Wonderful. Well, hello, everybody. I am David Jones-Gilardi. At least within the last 3 years, I've become a Gen AI nerd, right? I don't think many of us, well, actually, no, I've heard from enough of you at PyData that a lot of you folks were already doing machine learning and stuff like that well before the Gen AI explosion, right? But I have, I've come to this, I've been a coder for 30 years now, right? I've coded a bunch of different languages and all that kind of deal, and obviously loving my days with Python and such now. I love learning. I'm a big fan of Richard Feynman. Anyone know Richard Feynman? And he's known for being able to teach extremely difficult topics to anybody, right? And I've always kind of loved his approach. So anyway, I'm not saying I'm him. I want to be very clear about that. But that is something that I'm after, is just helping others learn along with me. So why don't we, here's my quick agenda. So what I want to do here is I want to first just talk about the problem space, right? What is it that we're trying to solve with not just agents, potentially multi-agents, evals, things like that. We'll talk a little bit about evals, what they are, what can you use them for, right? Has anybody already, by the way, used, I'm going to point you out a bunch today, Rebecca, but has anybody already used evals with agents or anything like that? So I got one. Okay, so I got maybe a third of the room, right? So we're going to spend not long in slides, and we're going to do more demos and code, right? So I like to show live stuff and things like that, and then I have a bunch of resources for all of you at the very end. So the problem space. So while, what I call the kitchen sink, and I heard yesterday mega prompts, right? Or I was calling overly complex prompts. These aren't the only two things, but especially now in this agentic age with MCP, right? Model Context Protocol, the USB-C for tool calling and such like that. The sheer amount of tools that we now can connect to with our agents has just exploded, right? And there's also a lot of tools that you can use to very easily and very quickly connect these tools up to your agents. Well, what does that mean? That translates a lot into these big kitchen sink kind of agents where you're like, oh my God, I can just connect up all the tools. And there are ways you can do this. Some models are better at being able to handle that compared to others and such, but there are diminishing returns if you go a little too crazy with it. And on the right-hand side, this is just kind of I don't expect everybody to read all that, and I'll show you some of this as we go. But this is like an example of just this overly complex prompt. There's too many instructions right in here. This is actually coming out from a deep analysis multi-agent kind of setup. Actually, that's not the multi-agent one. But this can lead to, to errors, to all sorts of, agents can get confused. They can kind of stop what they're doing. If you're using a model maybe that doesn't have enough capability, or is a kind of a small model, it may not be able to complete your task, right? So we want to address these two things, and that's what we're after here today. Okay, so one of the ways to potentially address both of these things is in using multi-agent systems. Now, I say potentially. Because there is no guarantee. I want to be very clear. There are times where using just an LLM makes sense, or using just a single agent, or using a multi-agent, or doing none of that and just doing things like a traditional way, like how we've done it for so long, right? But in this particular case, what I'm going to show you cases where say, a single agent or these overly complex cases can be broken down in a multi-agent system that will actually help us achieve our goals a lot more readily than if we didn't do that. But the key thing about a multi-agent thing is, at least in the way that I'm proposing it here, is that each agent is going to be specialized to doing a specific task and doing that task well. So if you compare real quick, right? So on the left-hand side, I just have a screenshot. I'm going to actually show you real stuff here, but I want to start off with this, kind of build up the foundation a little bit. So on the left-hand side, I've got a single agent. This is, by the way, these agents. I should set up the requirements a little bit. So what these agents are doing, they're just like simple equation-solving agents, right? So I'm going to throw some equations at it, and its job is to break it down and actually solve and give me the right answer, right? But part of the requirement here is that what I want to do is I want to ensure that, one, obviously the answer is correct, but then two, that I get a nice, concise response. I want my response to only be the answer, right? Imagine if I was using this in an application, I may not be doing a chatbot. I may not want all the reasoning in the conversation. I just want the answer, right? That's what I'm after. So on the left-hand side, I've got my single agent. On the right-hand side, it's the same exact set of instructions, right? Same exact set of instructions, but what's the difference here is where on the left, the single agent is essentially, it's got the whole set, and it's not even a big set of instructions either, right? But on the right side, I have two agents. One, its job is to break down the equation into solvable steps, and then the second one, its job is just simply to solve, right? Solve and return. Okay? And then, so one thing you can notice is that in both these cases, in this very simple example, they both get the right answer. That's not the issue here. But notice the verbose response of the single agent. But in the secondary one, in the multi-agent, I have two. You see the first AI response to the second one. Well, the first one is just that's not actually coming out into my end application, right? It's that last one. I get just the response. That's what I'm after in this particular setup. Now, same kind of thing with the overly complex prompt. This is a case of doing like a deep analysis kind of setup where I'm asking what are the dangers of too much screen time in kids, right? I have a 5 and 7-year-old. That's actually pretty relevant today with screen time and all that kind of deal. And so what I've done here is this overly complex prompt in the single agent, and honestly, it doesn't really ever finish the task. But the multi-agent one, and I've got a little fun surprise on that one, is able to work through it because each individual agent of part of the flow is breaking down the task into digestible chunks that it can understand. Okay, great. So that's the setup. Those are the things we're going to go over, right? So then what are evals? Evals are structured tests that measure the quality, reliability, and effectiveness of agentic applications. And the real goal here is to provide a framework that will give us an ability to get consistent and measurable results out of something that is inherently non-deterministic. Rebecca was talking about some of this stuff yesterday, right? That agents, because they're powered by LLMs that are by their nature non-deterministic, from an application programming standpoint, right, that can be challenging to test, especially when we have a deployed application that actual users are using, and you're trying to get some kind of and I'm talking not just chatbots, right? Chatbot, if you're having if you're doing like conversational agent stuff, you kind of expect that it's going to have a conversation like a human would. But when you are talking about, like, say, application interfaces and that kind of deal, you need to ensure that you can get a deterministic result, even if the underlying data itself isn't. So that's what we're going to use evals for. Okay, so what can you use them for? Now, to be clear, this list is not exhaustive at all. But these are things that I use a ton. I use evals for a ton, like model-to-model comparisons. Especially, the landscape of models right now is pretty insane. It's starting to settle a little bit, but we still have some huge providers with, they're constant releasing new capabilities. And so how can you, again, compare them? If you have an existing application, existing agents or whatever with existing prompts, what is a good way to be able to compare them in a fair way? You can totally, in the tools that I'm using today, you could totally just eye it, be like, wow, this Llama 3.1 over here did not do nearly as well as like this latest GPT-5. You could see it, but I want to be able to do this more from a quantitative standpoint, and something that I don't always have to be looking at, right? Something that I can set up in my own systems. Generating consistent and measurable results, that is a huge one. Tracking regressions and errors. This one I find particularly useful. How many here have ever made what you thought was a really slight modification to a prompt and just had something completely go off the rails? Yes, thank you. We're all there. We all feel the pain. So this is really great because once you have your eval set up and such, you can easily then integrate them to like a CI/CD pipeline, right? And now as your team is developing or you're developing or whoever, right, it can be watching. It can be watching for any kind of anomalies, right? And if something falls off a cliff and you see that come up in that pipeline, then great, right? You don't have to sit there and look at every single response all the time. Being able to test agent effectiveness, how well is your agent, is it concise? Is it correct? Is it hallucinating? All sorts of things, right? And then that last one there, this judging agent responses, LM as a judge. I've seen this come up in multiple talks so far this week, right? I always find this funny. It's the same thing, by the way, with structured output. Structured output has now become more and more of a thing that a lot of the newer models are using. Plus, there are tools that allow you to get structured output. And I find it funny that structured output tools tend to use LLMs to provide the structured output, even though you're addressing something from from an LLM to begin with, right? It's the same thing with LLM as a judge, right? So we're using external LLMs to then judge the output of our agents, and we'll see this happen live. Okay, so I did promise that we're going to only have so many slides, and we're going to get into fun stuff. So let's go ahead and do it. Now, what I'm going to do is I'm going to cheat. I'm just going to run something, and then I'm going to come back to this. Okay, so here's what I want to do. I want to do a little bit of a setup. So for one, the agentic tool that I'm using here is something called Langflow. You can probably see that on my shirt. Langflow is an open source visual studio for developers used to build out agentic Gen AI RAG workflows in a drag and drop, low code, no code way, right? And so I have some of these examples in here. Now, by the way, for those people who are totally like, dude, but you came to a Python conference and you're talking about doing like low code, no code. All of the stuff in Langflow, it's all Python, right? This is all Python under the hood. It's all modifiable. You can make custom things. You can do all sorts of stuff. But it does. The whole point of it is it makes being able to build, iterate on, whether it's agentic Gen AI stuff, workflows, like extremely easy. It is also model agnostic. So today I'm using LM Studio. Are you guys? I know Ollama is like very popular. Anyone use LM Studio? A couple. So like, I'm not. My goal of this talk isn't to like go on like which one's better or anything like that. If you haven't used LM Studio, the visibility you get from it is really nice, right? And it's similar to Ollama in that you can run local models and everything like that. And as a matter of fact, as that thing that I kicked off that I said I'll come back to, this is LM Studio, right? So I've fired up Gwen 3 for what we're doing, and it just gives you some nice visuals and such like that. They both have their pros and cons, but yeah, I'm using this today. So Langflow itself, like I said, it's totally model agnostic. You can use just dozens and dozens of various providers. It doesn't lock you into a particular vendor. That's the whole point, right? So we have flexibility. And I know for me in my own application development, it is not uncommon that I'm experimenting with many models until I really find ones that work. Or I might even be using multiple models, depending on what I'm doing, right? Now, this example here, this is that kitchen sink I was talking about. This is that image I had, right? So let's say that I have an agent here. It's super easy for me to come in and I can grab whatever components. It could be MCP, by the way. There's, this thing's fully supports MCP and all that. I'd pop it in a tool mode. I can just wire it up, right? Great. And what that leads to is I can have scenarios like this. Now, depending on the model you're using, it might handle something like this, okay? Especially something super important is that your underlying tools, the names, the slug, the description, they need to be very unique and descriptive. That way your agent, because this is what your agent's going to use to determine what tool to use, right? But even if you've done that very well, and as you start to stack up the amount of these tools, you can start to confuse an agent, right? So this is one thing. And then, like I said, with the, I'll say the mega prompt. I'm going to steal Rebecca's thing from yesterday and say mega prompt. Where we go? Yeah, here. Here's an example of what I've essentially done is, this is a case where in this deep analysis agent, its goal is you ask a question, and then it's going to break it down to a set of sub-questions. Then it's going to do some research on those questions. And then it's going to take that and it's going to maybe, do some review, fill out some URLs, give you links back, and then it's going to have another one that kind of like, grades the whole thing and then gives you the final output. So there's a lot going on in this particular case. Now, I'm not going to pretend this is like the most optimized prompt in this case, but what it does, right, is it doesn't finish the task. Now, you might argue, you might see up here that I'm using GPT-4.1 Nano, and like, dude, use a bigger model. Come on, right? And you can, right? Like, you can totally do that. Like, this is GPT-4.1 Mini. It works. It gets a little bit through it, but not quite, right? And this is a really great case where breaking this down into a multi-agent scenario, even with a smaller model, can give you much better output. So if we take a look at this one, now here is the same exact task, set of tasks. But what's different is each individual agent is specialized to a specific thing, right? So this first one is the one that's responsible for creating the questions, right? Notice I'm using Nano across the board. The second one is the one that is going to go do the research. It's going to go out into the web. It's going to go find information on whatever I'm researching. It's going to pass that back, and so on and so forth. So I have this whole set. But what's interesting is now I'm using Nano in this case, and it successfully goes through, does the research, does the checks against the sources, does all of this, and then provides me with this nice final answer, right? And so here I'm using the same model that I did before that failed in a single agent standpoint, but it is better able to manage this in this multi-agent scenario. Now again, is this a prescription? Is it saying you always have to do this? No. It absolutely depends, right? It totally depends. Okay. All right, so I just wanted to show those kind of examples. Let's see if this other guy's running. Okay, he's still going. So now these tests that I'm running, and I'm going to get into the eval stuff here in a moment. What I've essentially done is I have 3 different agents, right? And I have one set up. These agents are the ones that are responsible for breaking down equations and then solving them. So I say math question single bad. I put quotes, I put bad in quotes. Why? Because that's not always, it depends on your requirements, right? You'll find in a moment that this single one actually gets the right answers, it does the right thing, but my requirements is that the response is only the answer, not all of the reasoning and things like that, right? So I've kind of set it up in such a way in this case, that I'm guaranteeing it's not going to be able to do it, but it is kind of. I think that's the reality actually today, especially when you are trying to get an agent to just respond with an answer that is then correct, and then that's where you see it kind of break down. This no explanation one. What I'm doing there is it's still a single agent, but I've essentially told it, hey, just give me the answer, right? I don't care about all your reasoning. Just give me the answer, and then that final one is going to be the good one where we break it down. So let's go ahead and take a look real quick. All right, so this is LangSmith, by the way. So I'm using LangSmith as the eval framework. I want to be clear about something. I'm using LangSmith, and LangSmith is great. It actually does a really nice job of this, but you're not required, it's not the only thing, right? You've got Arise. You have Arise Phoenix, which is open source if you care about that. There's LangFuse. There's LangWatch. There's all the Langs. Everything has Lang in it, including Langflow, right? So LangSmith is a great tool. There are others, and as a matter of fact, one of the videos, or one of the resources I have at the very end, is a video that goes over all of these, right? So if you haven't really gotten into an eval framework or you're just curious, the video will go over all of these. So here in LangSmith, you'll see these data sets and experiments, and there's this math data set, right? So this part's important because this is going to be my ground truth, right? This is going to be the part where I'm saying, hey, these are the things, whether it's my application, or whatever it is that I'm testing, I'm going to pull these out of my domain, right? In this case, I'm just saying, hey, I want you to be able to solve for, these various equations. But the key thing is that I can put this here in LangSmith, whether I do this programmatically or if I do this here in the UI. All the stuff, by the way, that I'm showing you can do programmatically. So I know for me, sometimes I like to build stuff up like a CI/CD pipeline. I don't want to have to worry about going into the UI. I want to be able to just do it at code. You can absolutely do all this stuff in code. Right, so I've got a data set, and it's called math data set, really simple. And then what we're going to do is I come into one of these. Let's go ahead and look down here. Right, and you can see it's asking. So it's all the code, and I'm going to show you the code here in a minute. The code is just iterating through, right? It's iterating through these questions, and it's asking the agents about them. Now, like I said, in this first one, and this is the single agent case, it actually gets the right answers, right? It does a very good job of getting the answer. It reasons it out and everything like that. It looks good, but it's not concise, right? I'm not getting that single response that I'm looking for. And then if I go to our no explanation one, right, come down here. Okay, let's see. Well, you notice, so the goal here is I told it in its prompt, just give me the answer. But you'll see when we look at the results, the underlying results are wrong, right? It tends to get these wrong in this particular case. I've kind of hobbled it, honestly, in the way that I'm doing this. But so could I finagle? Could I massage the agent to give me the single answer? Yes. But in doing so, I've kind of hobbled the thing. And then this last one here, okay, if I open this up, you can see now the first agent, the one that its job is to step through. I want you to break down the equation. I want you to put it in solvable steps. And then the last one solves. And then it just gives me an answer, right? And this one, I have very clear control over what the response looks like and everything like that. And again, we should see in the eval test results when we get there that it not only gives me concise answers, but then also gives me the correct answers. Okay. All right. One other thing, while let's see, is this still? Oh, good. Yay, good. We'll get to that in a minute. Okay, great. So it finished all of its tests and everything like that. So as part of Langflow, the agentic framework that I'm using in the other screen, it's super easy. Like if you want to hook up to like say LangSmith or Arise or anything, you just need a project ID from LangSmith and an API key, and that's it. You put those in your .env file. When you fire it up, it'll automatically connect and do everything. So if I come over here to monitoring and stuff in LangSmith, and I look at the last hour, right? All this stuff, all the data that I start getting, like some of the information here, trace counts, that kind of deal, the tracing itself. If I come in here, I'll get all the traces and everything. That's automatic. So that just happens, right? So if you're looking for a way to immediately, just very quickly be able to hook your agents right up, you essentially get all this for free. I don't even have to write up one line of code, right? I can literally just put the ID and the key in my .env and launch Langflow, and I'll get all that information. Okay. All right, so I said before that I would prove. Let's see what happened here. All right, so that's right. I've got 3 sets of tests that I ran. They're all essentially the same exact test, but they're just hitting these different agents. The one with the single agent that I did nothing to, the one with the no explanation, and the multi-agent. Now check this out. Notice here, this is the single agent. Notice each of the answers are correct. Now what's super cool is that this output you see, by the way, this is using Pytest along with LangSmith, right? How many of you, I know I'm at PyData, how many of you were using Pytest, right? Yeah, I figured that was like a dumb question here, but I wanted to ask it anyway. Yeah, so what's super cool about this, and argue about LangChain if you want, right? LangChain has its pros and cons and everything. But the LangSmith team, I think, did a really nice job of making this super straightforward. The whole point is that I can wire this stuff up in my existing Pytest framework, in my existing unit test, in my existing integrations, just with adding some decorators. Right? It's super easy to do. And I'll show you in a second, like this output that you get, this kind of nice output, is actually just coming from an option you give when you run your tests. And the whole point of it is to like mimic what you'd see in the LangSmith UI, but doing it at the terminal. You don't actually have to use the LangSmith UI if you don't. But what I want to point out is notice the numbers here. So great, the single agent got everything correct, but they weren't concise. Now, our poor agent, in this case, our single agent that had the no explanation thing, like I said, the one I kind of hobbled, notice that none of them are correct and none of them are concise. And then the real one, the fun one, yeah, good, is that the multi-agent got them all correct and got them all concise. So why don't we go ahead and look at those results. So this is now, if you do everything in the command line, by the way, that's great. It's a little more bare bones. Obviously, if you want the fully featured stuff, you come to the LangSmith UI. But here's what you can do. Check this out. So notice if I say click into one of these. There it goes. So I'll get this kind of like verbose output. But remember before I mentioned being able to use an LLM as a judge, right? So now I've actually set up a conciseness judge and a correctness judge. And we're going to see this in a code in a moment. And so we're using an external LLM to then determine the correctness and conciseness of these responses. And what's super cool is if I hover over these things, it'll give you reasoning. So it'll let you know. So you can come in here if something does fall off a cliff or something unexpected happens. You can come in here and you can see what the model's reasoning was. Okay. All right. Okay, so with that, let's just look at some of the code, right? Let like I said, you can just tag this right on to your existing Pytest code. It's super simple. So in this app, by the way, this reference app that I'm running, this is the thing where all the scripts are going and all that. This is all on a GitHub repo. I'll have stuff for you at the end on that and everything. Use it or not use it to your heart's content. The whole point of it is just to give you a nice working reference example of doing something like this, and hopefully as simple as I possibly could. But here, a couple things I want you to notice, right? So when I'm setting this up, notice support for open evals. Something really nice that the open evals package gives you is they have default prompts in there for LLM as a judge, like correctness, like conciseness, like hallucination. You can just use those out of the gate. Or if you want, you can totally make your own, right? You can totally build your own judges. So I'm setting these up later because I'm going to use those here in a moment. So right here, this is all the code I need to set up the correctness evaluator using open evals as a judge using, in this case, GPT-5 Mini. You could argue whether or not you even need to use GPT-5, honestly. We found that sometimes smaller models, some of the older models, do a really good job of being judges and not like overly reason things. But you just set up your evaluator here in this prompt, since I'm using the open eval one, I'm just passing that to it. Now, I could have just created my own, but I'm using the default one. So right here, right out of the gate, I've got 3 LLM as a judge, judges, 3 LLM judges. There we go, I'll say it like that, all right? And then over in my tests themselves, if I come up a little bit, you can see I'm just pulling these in. I'm just using correctness and conciseness here. So when we come back, notice these 2 judges. These 2 judges are corresponding to these 2, right? It's coming right out of code. So whatever judges and such like that you set up in your test code is what's going to show up in the UI. Okay. Now, before I mentioned I had this math data set, I'm literally just talking to LangSmith in this case, right? So I set up the data set in LangSmith, and I'm going to use that. I'm going to pull that down. So if you were to look at the code here, you see me where I'm using the LangSmith client. I'm reading I'm pulling that stuff down. Just pretty simple and straightforward. Here are some of the decorators I'm talking about. So I've got regular PyTests, right? It's just a regular setup. But I've got a couple extra decorators that I put in place, and that alone is enough to now kick all these evals off. So I get this capability. And then finally, this call Langflow API, right? All I'm doing, so in Langflow itself, every one of the flows that you create has a backend API, right? You can do it with this API. You can use the OpenAI Responses API, right? There's multiple ways that you can skin this. So you can just directly talk to them. It's the same way that you would wrap an application in and execute these with your application. So I'm literally just calling them in. And in this case, I have my provider, my model name, and then this is just, in Langflow, every one of your flows has a flow ID, but you can also give them nice like English names or just regular names there like that. I like using these because it's easy to reference. Flow IDs can, it's just a UUID, right? So I'm not going to memorize a UUID, but I can memorize that pretty easily. Okay, so you can see here, right? This is just calling. And then what's super cool as well is this. LangSmith also includes another little decorator, this @traceable. I can wrap. In this case, I might be calling the Langflow API, but I don't have to use Langflow. I could be using whatever other agentic framework, right? I can just put that @traceable around whatever method, and then LangSmith will grab it and will actually start to report on it. Okay. All right. So hopefully it gives you a good idea of what is going on from that standpoint. And just a couple wrap up. I know we're getting out of our time. Like I said, so this is the GitHub repo. Now there's this QR code, if you're interested, will bring you to a set of resources. One right here. If you are using Pytest and you want to use LangSmith with that, it's super straightforward, right? The docs are pretty easy to follow. So that'll bring you right to that. The repo, obviously, it'll bring you to GitHub repo. And then these 2 links, again, these are all in the GitHub repo. These are those videos. There's that one, this AI observability explained, is the one we'll go through all the different LangFuse, LangWatch, Arise, all that kind of deal. And then I have a video on creating code evals using LangSmith. And then finally, this is for Langflow itself. So, again, Langflow is open source. You can UV pip install it. You can use a Docker container. You can install it by executable. And it's a nice open source agentic framework you can use to build out your flows. And with that, thank you. And we all have time for questions, yeah. All right, anybody have any questions? Yes?
So, I was wondering with multiple agents, one of the things I've seen even just using LM as a judge is you're in some ways compounding the non-deterministic output. Do you have any ways to mitigate that or like, because particularly if you have multiple ones, you're passing LM output to another LM.
Yeah, 100%. It's so true. I made that, I was kind of joked about that in the beginning with using non-deterministic LLMs to then do things to fix things that our non-deterministic LLMs are doing. For one, you can create evaluators that do not use LLMs. You can score them yourself. So if you don't want that particular kind of constraint or you feel like you don't trust an LLM as a judge, you can absolutely create your own functions that then you have your own scoring methodology that you're using to judge them, right? You can also do human in loop. Like there's multiple ways that you can kind of skin that. So it just depends. But I guess if you are using LLMs, I mean, part of it is finding the right model, right? And being able to, and part of that is also gaining some confidence. You gotta run some of these things, right? What's the output look like? Is it consistent with what you expect, right? Part of that's also, in this case, I use these like simple equations, but that's also going to depend on your data sets that you're using, right? And the types of things that you're doing. So I think there are multiple ways to kind of address that.
Yeah, I think though sometimes with LM as a judge though, particularly because the judge is non-deterministic too, and then you tweak something, it's harder to tell if you're actually improving or there's like a range, right? And then like you have to see like, oh, it has to be outside of this normal scoring range to see, oh, this is an actual improvement or this is an actual.
Yeah, and honestly, like anytime I've actually set up any of my own eval projects, there's always an initial period of like you have to test it and check it. Right? And is it giving you the kind of results that you expect? And usually that to me is a sign. If it's not, and I've totally run into that, it's a sign I need to change something somewhere, right? And I need to make some modifications. And then, as a matter of fact, that's where I found that of all things, like using like 4.0 mini ends up being a great judge model for some reason compared to like some of the newer reasoning models. So yes, there is an initial period where you need to check your own evals. Do they make sense for your application and for your need? And once you've then got some of that confidence, I think you can then kind of establish a baseline and go from there.
So you had the two metrics, correctness and conciseness. Do you use two different judges for that?
Yeah, the conciseness and correctness, yeah. I mean, at least I did in my case. Yeah. And again, I'm just using the default. It's funny, funny enough, I think. So I've got this broken down. So like this reference app is literally just using specifically, I tried to do it as simply as possible. And I am using, the LangSmith decorators with OpenEval and that kind of deal. And so you don't see the prompts themselves. But if I remember, let's see if I remember, because I also had some other implementations. Right. So like you can write these yourself, like I mentioned, right? So you're not limited. So there I was just using conciseness and correctness, but if you don't want those and you want to do something else, right, you can write your own prompts. So honestly, Arise, any Arise users at all? Oh, okay. Have you used Arise? Have you used Alex?
I'm just getting started in using Arise.
Oh, are you using Phoenix or are you using their paid
Phoenix
thing?
Arise.
Oh, you're using Phoenix. I don't think they have Alex and Phoenix, but if you've already got like an account, they have this agent called Alex, A-L-Y-X, I think. It is excellent. You can create pretty much any kind of evaluation that you want. You just put in there, you just tell it, hey, I want to create an evaluator that does this. It creates the prompt and everything for you. It does a really nice job. Right, so anyway, there are multiple ways to do that, but back to your question. Yeah, in this case, I just use correctness and conciseness. I was using what is there by default as compared to doing something super custom, but you can create whatever. Any other questions? Yeah.
Have you done comparisons between, let's say, like a single agent workflow with just like a very large model, and then multi-agent workflows with small models.
Oh, for sure.
And I'm curious, like, for cost, which ones?
It's oh man, that's such a great question because, matter of fact, I'm gonna pick on Rebecca again. Rebecca and Sebastian from yesterday, both had great talks on this kind of stuff. Sebastian even talked about cases where sometimes having a bigger prompt can give you other benefits from a cost perspective and such. I think it really depends on what your agents are actually doing because every single time you pass a big prompt, right, you're paying the cost of the tokens. You could argue that that's negligible compared to some of the context and some of the other things that we're doing. But I have definitely seen cases where some models will not do okay with that, right? So depending on maybe some larger models will be able to handle it and then some just can't, and it's better to break it up. But then like for the Nano case, Nano is so much significantly cheaper than what like 4.1 would be that I can run it multi-agent. If you notice that my prompts are much smaller, they're able to finish the task and everything, but it's so cheap that it is overall cheaper than it is when I use the big models. So that's part of the experimentation. And that's part of why these evals are important, because then you can test them and you can make sure you're getting out the types of answers that you're looking for. Like, depending on what your tolerances are, like you might be okay, for certain cases if like, a smaller model in certain, maybe is not as concise as you would always want it to be, but maybe you're okay with that and you're okay with the price point. Another thing to think about is then, just performance. A lot of the smaller models are slower than the larger ones, right? So again, it is one of those things that's exactly where you can apply evals to kind of figure it out. So. All right, well, cool. I think that's it for questions. I appreciate everyone's attention. Thank you.